In the 18th question, we have linear upon quadratic, okay, and once again the approach that we want to follow over here is write that linear as sum of one term which is having derivative of the denominator and another term which is a constant. So this numerator 5x minus 2 will be written as a times derivative of denominator which is 6x plus 2. Can you observe 6x plus 2 plus b? And since this is true for all values of x, one of the ideas is you can substitute some value of x to get a and b. Let's say form two equations to get a and b, or we can simply compare the coefficients of x and constant term. From the coefficient of x, 6a is equal to 5. Okay, coefficient of x is 6a, that is 5, so that gives me a is equal to 5 by 6. That's the first thing. What next? Constant term minus 2 is equal to 2a plus b. Okay, and that tells me since a is 5 by 6, this is 2 times 5 by 6, which is 5 by 3. So b is equal to minus 2 minus 5 by 3. Okay, this is minus 11 by 6. That's what you get. Minus 11 by 3, not 11 by 6. It's minus 11 by 3. Right? Let's check that value again. This is minus 11 by 3. Okay. And 5 by 3. 5 by 3 minus 11 by 3 will be minus 6 by 3, which is minus 2. That's okay, right? So a and b have been found. Okay. Therefore, the integral will be equal to what? A times 5 by 6 times integral of this derivative 6x plus 2 upon that 1 plus 2x plus 3x square dx minus 11 by 3, that is the value of b, plus another integral dx upon, this is b, right, constant, 1 plus 2x plus 3x square. We have written that complete integral as sum of two integrals in this manner. So this is 5 by 6 I1 minus 11 by 3 I2. Our target is to find I1 and I2 separately. Once we find I1 and I2, then we can write that expression, complete that expression by writing the values of I1 and I2. So I1 is pretty simple. This is 6x plus 2 upon 1 plus 2x plus 3x square dx. The important thing over here is this 1 plus 2x plus 3x square can be written as t, and this tells me x. Okay, this tells me 6x plus 2 times dx will be equal to dt. And we have actually planned using that idea, right? Derivative of the denominator is with a over here. That 6x plus 2 is nothing but the derivative of denominator. Yes. So this becomes, okay, dt upon t integral. This is log mod t plus constant, which is log of mod 1 plus 2x plus 3x square plus c1. Let's call this constant c1. This is I1 for us. Okay, once we have found I1, can we also find I2? Yes, we can find I2. Now for I2, we need this integral. And for finding this integral, we need to convert this into a perfect square first of all. Right? This is 1 upon quadratic form. We'll have to convert this into a perfect square. So let's focus on that particular part first. We have 3x square plus 2x plus 1. We can take out a 3 common. This becomes x square plus 2 by 3 plus 1 by 3. Is that okay? Yes, that looks simple. That looks simple. And what next? So this can further be written as 3 is okay. This is x plus half of 2 by, this is 2 by 3 x, mind you, right? Half of 2 by 3 is 1 by 3 squared, okay, and 1 by 3 square will be subtracted. This is 1 by 9 plus 1 by 3 is already there. Okay, so this is 3 by 9, this is 1 by 9, this subtracted will become 2 by 9. So this is 3 times in the bracket x plus 1 by 3 squared and plus 2 by 9, which is root 2 by 3 square. That's the expression that I have. For I2, that's the expression that I have, that's the expression that I need. Once I have that expression, what I can do is, I can easily write this integral now using a formula. So I2 over here is this. Let's observe, I2 over here is this expression, and what does that give me? Integral of this I2 will become integral of dx upon 3 in the denominator will come out, okay, and what remains is x plus 1 by 3 square plus root 2 by 3 square. And this is similar to x square plus a square, right? 1 upon x square plus a square, that converts to 1 upon a tan inverse x by a. Okay, this 1 by 3 is outside. 1 by a means the reciprocal of this will be 3 by root 2. Tan inverse x by a is what I get, and x plus 1 by 3 upon root 2 by 3 multiply by 3, this becomes a 3x plus 1 upon root 2 plus constant c2. That's the other constant that you need. This 3 cancels with this 3, and this is I2 for us. This here is I2. Once you have found I1 and I2, the next thing that you want to write is value of I from there. Therefore, I will be equal to what? 5 by 6 times I1. Now, this is 5 by 6 times I1. 5 by 6 log of modulus 1 plus 2x plus 3x square and minus 11 by 3 times this I2. So, minus 11 by 3 root 2 tan inverse 3x plus 1 upon root 2 plus, what do we have? We have this constant multiplied by 5 by 6, this constant multiplied by minus 11 by 3, which will convert into a new constant c, and yes, that is the required answer for this complete question over here. Now, in all such questions of linear upon quadratic, linear upon root quadratic form, you'll have to follow similar steps. First you write this expression. You find the values of a and b by comparing the coefficients. You write in terms of two integrals I1 and I2. Then you solve I1, you solve I2, and write the final I in terms of I1 and I2 there. Right? That's the approach that you will follow in all such questions. Right? So this is the 18th question for us. Let me get aside. You can take a look at the complete solution over here, and we'll move on to the next one after this.